Please type your question in the Q&A box in the Zoom window, and I will summarize the question in the end of this to the speaker. Our next speaker is Mr. Davey Liu. David is leading a global team of more than 2,500 people responsible for the architecture, development, and engineering of AT&T's next generation software-defined network automation platform, an open source enabling AT&T network visualization and target network system transformation. Since joining AT&T Bell Lab in 1987, David has served in various leadership positions at AT&T. He has led numerous automation initiatives in AT&T that result in multi-billion-dollar saving. He won the AT&T CIO 100 Award in 2010, and David holds 54 patents and received many prestigious industry awards, including 2015 Chairman's Award from IEEE, Communication Society for Network and System Quality and Reliability. And David is 2017 CIE AAEOY Asian American Engineer of the Year awardee. So that's welcome, Mr. Liu. Could you share your screen, David?
Yes, first, let me just make sure that you guys can hear me first.
Yes, we can hear you clearly.
Okay, then share the screen.
Yes, we can see the screen.
And then let me move to the, okay. So you can see in the display, the show mode, right?
Yes, we can see everything clearly.
All right, good afternoon. I hope that you guys are still very energized after hear two of the very, very impressive talk this afternoon from my colleagues, Professors Zhang and Professor Li. And I think their talk lays great foundation to what I'm going to take you through. The rapid advancement in mobile and broadband technology has opened previously unimaginable new use cases. Technology advancement, including the convergence of a hardware, you heard a lot of things that talked about by Dr. Li just a minute ago, and the software, physical and virtual networks, and the open architecture, industry-wide APIs, ultra-fast speed with extreme low latencies, high capacity, improved reliability, quality, and the security, and AI-enabled sensors. Just think about Dr. Li's talk, okay? And all those rapid change the entire business landscape. So what I will try to focus today is talk about a little bit about the fundamental convergence of the network technology in the recent decades, and then also give you some of the ending with some of the great use cases, give you a flavor of bring research work and the industry work all together when we merge, okay? So I will very briefly touch on industry landscape, innovation drivers, the future, and emerging technologies and IoT use cases, and then we land some time for questions. I want to start with some of my background, since Dr. JC already did a lot of a good introduction. I will just move forward very quickly, but if enough to share with you, I feel very, very blessed to be associated with one of the best company in the world and continue when the day I joined the company to this day is using innovation and creativity to drive our future, okay? And then let me start with the industry landscape. So what I would like to talk to you about is that if you think about the industry landscape, okay, this is on the left-hand side. You see that the on the left-hand side is all the chips, sensors, quantum computing, the fiber, the hardware is explosive development. Recently, I was on a CIE gala, and I was lucky enough to be on the same table with the NVIDIA's founder and CEO. And then when he talked about the hardware improvement that he made on the graphics chips, is just absolutely amazing. Okay, you hear some of the earlier video talking about TI, talking about the Encore, and talk about AT&T advancement in those areas. And these are the hardware advancement. And then you move further to the right-hand side, you see a lot of the software in the center. In the software control the world with powered by cloud, software by super powered by cloud, open APIs, software as a service, network as a service, open source. And why all of a sudden AI is so important? For those of us that we involved in the industry long, we know AI was a big topic back 30 years ago. But the AI back 30 years ago, very interestingly, was almost like people think, wow, that's academic, it will never happen. But with the advancement of computing, the chips, the software, and the cloud computing is enable AIs to take on its own new phase and advancement. And then you're looking at the business and you go into the real society, things that impact us. It's quite amazing that you see the world is colliding and converging. Okay, so now when we think about 2021 telecom trend, where we are heading, I personally believe we're entering into a super exciting connectivity world. You're talking about hyperscaler cloud and software-defined network running not only on a bunch of computers, but running in a hyperscaler cloud. 5G, and earlier you heard Professor Lee talked about the millimeter wavelength. And you know 5G is fundamentally based on those millimeter wavelength. Over-the-top solutions and value-added services, and you stitching a network services, it was so complex, takes hundreds days or months to provision and activate. And today just takes a few clicks to activate. Execution velocity, that is the speed we're talking about. And plus, because we take so much on to rely on the computer and in the cloud, security becomes a mandatory requirement. We have to guarantee it is secure. And just giving you nothing more, even more personal, is that my personal identity during the pandemic was stolen. Someone stole my personal identity, filed for unemployment benefit. Okay, and this is amazing. I never lost the job. I was still working happily and excited and very energetically for my company, for my team, for my organization. And yet someone filed on my behalf through Texas Workforce Commission for filing unemployment benefit. So someone must have got a hold of my IDs through internet. So this becomes even more important for us to worry about. I also would like to just take you guys back, just emphasize one thing from this chart, is the speed of innovation moving from agricultural revolution from 10,000 years BC, 12,000 years from today, industry revolution, and the digital revolution into the next revolution today onward is really changing from thousands of years to 100 years to decades to only years, months, weeks, and days and hours. This is the changing speed we're talking about. Now, let's talk about some economic impact. I just want to draw a comparison of the railroad industry happened in the 1850s. Okay, this is a steam machine that invented, they drove the expansion of railroad in changing the perspective. Mankind, large scale shipping is only around the river, and railway really changed that. So you think about what is the impact railroad brought to the world industry in a span of 15 years, 17 times. Within the same 15 years span from 1995 to 2010, a much large base of the world economy benefit by the networking alone, attributed to the networking advancement that is 40 times X. Okay, so just keep that in the background. Furthermore, the speed further moved forward. We used to know software development, hardware development takes several years as a cycle time. When we move into a DevOps mode, really shifted entire spectrum of what we do. My team today develops code in every 2 weeks in iteration. The concept of my client, my business partner, AT&T customer wants something, you have to wait for a year to get it. It's already eliminated completely from our vocabulary. It's always whatever you need, okay, we just iterate into the next one. This is something that I never experienced in a career world, okay? And so therefore, I would like to kind of give you a little bit of background of AT&T's innovation in the past, whether that AT&T people invested into the technology innovation and helped to change the world. Here is something that I always feel so proud of associated with this company name. If you think about many things that come so taken for granted by every one of us around this call, but they all find good origin back to AT&T Bell Laboratories and today's AT&T lab. 1925, the first fax machine. Now, of course, without go saying, 140 plus years ago, we had the invention of the very first telephone, right? And you look on these things from the solar cell, the transistors, the first satellite, the information theory changing the landscape of entire what we know as today's computer science, okay? And you continue to think about fiber undersea, the laser technology. I had a Bell Lab supervisor who participated in the first generation of research work for laser technology, first generation of US missile technology. They participate even in testing on the Pacific Islands. Okay, a lot of those things happening, and some of the things coming much closer to home for me as a computer scientist, and today supporting a lot of things on this chart. All right, now here's also a very proud moment of Davey Liu. Okay, this is the AT&T Global Network. My team developed a software to control, orchestrate, activate, inventory, and monitor and proactively and preventively correct the problems in the network to make it the most reliable network in the world. And this is the size of our network. We literally transport on an average day 462.5 petabytes of data. And the other data I won't have time to read, you can read on your own, are some of the statistics about the size and global nature of our network. And this one gives you a sense, the 462.5 petabytes daily, just barely 6 years ago, we're only 25% of this. You look at on the left-hand side, 114 petabytes daily to 274, 2019 pre-pandemic, and shot through the roof. It's very significant network traffic growth. What does that mean? And this means translate to huge business for AT&T as we know today. And let's look at the emerging technology drives AT&T's future. First of all, I would like to highlight the point that I was making all along. In last 10, 12 years, since 2007, we saw literally AT&T mobile network, the network growth is more than 470,000%. This is literally how much our mobile traffic grew. And if you look at this represents a significant challenge to us, is that if we follow the same hardware model, it is not sustainable. You can see from the network left-hand side of the charts, okay? If you go with the hardware-centric network, it's a flatten up following the Moore's law, how much you can get every 18 months in advancement. But the demand, you see the dashed line of a blue line is going up. The only saving grace is when we move into a software-centric architecture, we can save the day. We already proven it, okay? And what does that mean, software-centric? You may ask David, everything is running by computer. But it used to be our all network gear placed in our network. You saw the earlier picture of the AT&T FirstNet. And most of the old generation of the AT&T telecom equipment gears, they are custom made on the left-hand side of the chart. Software, hardware, they're bundling together. They're customized together. So what we are trying to do is disaggregate the software and the hardware using commercialized hardware devices, what we call like the cloud, like the 386 architecture, and the computer as the pizza box, as the blades that we install in very, very large quantity, very, very large number, commercialized, not customized, but then we run the virtual software over it, okay? So this is what you will see, that over the last 7 years, since 2015, AT&T has been on this technology journey. Over 230 AT&T network function has been virtualized. If you look at the total virtualized traffic represents the AT&T function is roughly about 76%. 76% of AT&T's network function today has been virtualized. That including that we increased the usage of Wi-Fi calling, the software-defined wide area network, 16 times demand surge over 2019, and messaging, okay? And 3 years of growth just in 1 week. This is a kind of a skill we're talking about. The connectivity and proximity focus is very, very important. And this is leading me to talk about our fiber and 5G strategy. And 5G is very much built on the same radio technology Dr. Lee was talking about, the millimeter wavelength, okay, the radio things, but not for sensing, but for communication, all right? So let me just go on to talk about a little bit about 5G. What is the 5G? 5G it itself is a software-defined converged network. Why 5G, then you said? You already have LTE and 4G network that's enough for our current broadband network access needs. Well, guess what? Our study and customer demand show that's not fast enough. So the massive device connectivity, the ultra low latency requirement, ultra reliability requirement, better capacity, and ultra high speed. We never thought about mobile communication will require multi-gig services, and we are seeing it right now. And some of the very interesting charts and pictures presented by Professor Lee, it was actually very similar kind of a use case we'll be talking about later today. All right, so let's talk about the wireless evolution for a while. Just think about in last 40 years, how much changed the landscaping of the wireless network. We used to have a cell phone as big as a brick. The people are holding the thing is bigger than this water bottle to your ear to do your radio talks, okay? And in 1980, just think about 1980, the first generation of wireless network, what's the capacity? 2.4 kilobits per second. 2G is in between up to 64 kilobits. Then you're moving into 3G, that's up to 2 megabits per second download speed. With 4G LTE, we were able to provide anywhere between 8 to 80 megabits per second speed. Good, that's great, but not good enough. And if you look at a 5G, we're talking about 40 megabits per second minimum, and under the using the sub-6 gig spectrum to go up to 2 gig above using millimeter wavelength. Okay, there are some challenges we can talk about, but also with all the new technology coming up, we are achieving that. So let me just keep going. This one is a chart I love. For those of you, if you're interested in the wireless technology, this is a very, very good roadmap. If you think about on the left-hand side, start with 256 QAM. In this, and going through the carrier aggregation 4x4 MIMO. And if you think about this, these three I can present you as the following. Is almost like first, the human mankind, we have country roads. People walking over it, you create a small path. Then we create country roads. Then we build the large streets. Then we build initial highways. That's the 256 one. And the carrier aggregate is what? Is raising the speed, raising the speed. So it's like the highway, when I first arrived in the United States years ago, the highest speed allowed on internet, on the interstate highways is 55 miles per hour. Today, if you drive on the interstates in Texas, you know it's 75 miles, okay? The train travel 100 kilometers today. If you go to other countries, especially like China, they have a high-speed trains running at 350 kilometers per hour. That's the example of raising the speed. The 4x4 MIMO is what? Is increasing, adding more lanes to your highway. This is the analogy. Now, the technology of CRAN, which is centralized RAN, is that put the RAN processing power in a front haul fiber connectivity over cloud. Software defined comes in for 5G. The network slicing, massive MIMO, beamforming technology, millimeter wavelength, etc. All will add our capability. Then the software defined radio-based cell, neural networks, all advance into 6G. This is we're talking about 6G technology. But all this is talking about the AT&T and any industry telecommunication network. If you want to participate in this connectivity business, you need to develop the device intelligence, the new edge, and the fiber as foundational, because it's how fast you can take the over the air wavelength, very expensive, to underground over the fiber with unlimited speed and capacity. Okay, so now we talk about a little bit more about the software-defined network, why this is so important. Economies of the scale from standardization, white box hardware and software disaggregation. High speed in core and metro network from 100 gig to 400 and 800 gig and terabit speeds. We are literally in AT&T, we are swapping out the mega switch that used to, we are proud to talk about the huge switch that can blow your head away if you stand next to the fan, that it is capable of supporting the 768 gigabits per second communication speed. And we will be able to support 192 minimal terabits speed with commercial hardware and software running in the cloud. This is literally what we are doing by comparison, okay? Low latency by the 5G network and the 5G applications, and intelligent software control for core and edge functions. And that is the area have a broader, implications. And this is the area of my team that focus to help AT&T and help the AT&T industry to happen, make things happen. And I also would like to just walk you through a little bit on the 6G, because a lot of people may ask the question, what is it, 6G? We have not even fully utilized the 5G. Why we're even talking about 6G? Because the speed of innovation is changing. In the past, it's roughly 10 to 12 years each generation, then you move on from 1G to 2G to 3G to 4G, and to now to 5G. But we expect the time will be shortened, moving from 5G as the evolution to 6G. And what will 6G bring to us? The industry and the experts and researchers and the engineers alike are working together on this. And start with number one, extreme high data rate and the capacity, extreme low latency. And you go from clockwise and do 1 and 2 and the 3, extreme high reliability, extreme massive connectivity, and extreme low energy and the cost, and extreme coverage. These are the improvement we can look for the industry researcher working on to bring to the world, okay? And so now let me just focus a little bit more on the next generation IoT use cases, okay? So the future is here because you already heard from Professor Lee, you heard a lot of the cases of the research work on medical science. I personally feel if as an engineer, you want to work on something, either you want to work as a medical science, genetic engineering that benefit mankind in the next 10, 20, and 30 years, or you want to work as a software engineer and some specialized hardware related to sensor technology to make things happen around us, because they are huge, huge use cases. So this one gives you a summary of this. Let me go just skip this one and give you some very specific examples in the next few charts. And I'm sure there's some of you that if you pay attention, if you heard, saw the AT&T FirstNet, the video, you will saw something that the drone AT&T is providing for our FirstNet network. This is this concept what we call flying cow. It's a moving in the air using drone technology to be a moving cell tower. This is literally a moving cell tower, okay? And this one gives you a picture of the real device versus how they are logically connected on the right-hand side. And the next chart gives you more breakdown of the system elements, including you see the solar panel on the top left, you saw the cards and the tethered, all the power unit all the way to the device. And then you see the satellite cars together into tracking down all the huge radar, over here to track down this technology. And then if you think about this, the use cases from a driver, self-driving semi-truck to a no driver delivery vehicle to a sleeping vehicle traveling on the highway, automatically you sleep overnight and get to the place the next morning, and improve the quality of autonomous buses and reduce the operating cost, to say the least. And the smart city concept with those kind of connectivities. AT&T Business actually worked with several large cities around the country just recently. They're developing additional applications for them, that one of which including a graphical geofencing capability to filtering out and tell the surroundings for police arrive on the crime scene. Before you arrive, from the policeman's mobile device, they will be able to see exactly the geographic location and for the surroundings, not only external to the building, but the inside of the building. So this is just one of the smart city kind of solutions. You can see energy sourcing, management, and deployment, and using the big data analysis, using the smart grid, okay? And also smart water and waste management and medical science. There is unlimited opportunities in a virtual environment, as proven by the current pandemic. And by the way, one of the things, it will changing us forever when you think about post-pandemic, how humankind can thriving is with the computer technology, with the advanced connectivities, that the speed of the connectivities, all of us, we can work virtually from home. Why some parts of the AT&T fiber business is growing out of leaps and bounds. Why some of the residential house selling is going through the roof is because everyone is working from home today. So thinking about some of those implications and all the capability will be providing to the emerging services, the operating room, the expert that otherwise not be available for a surgeon or surgery that we are going through, and also the preventive type of the services that Professor Zhang was talking about earlier, talking about the immunotherapy for all of us, right? And now this is a very interesting use case. I am very happy to share with all of you. This one was my team's invention. We look at the software complexity, it's just growing by leaps and bounds. It's easy for someone architecturally say, well, let's develop, microservices. Let's develop APIs. I tell you, give you some simple numbers. My team today manages 5,000 microservices instances that we have to manage. It is really beyond our understanding in how we would manage it if one of them will go down and impact the whole ecosystem. So what we developed this concept is called molecular-based AI. If you look at all those things that are in red, in green, in blue, the blues ones are the stable ones. It's not being changed. The yellow ones are flashing that I needed some patch. I needed some changes, okay? The red ones are, you done the change. The green ones are coming in to kick the red one out. So what we designed this autonomous systems is they're designed to autonomously manage it when the yellow turns into red. When the red is turning into yellow, everything is done automatically mechanized, and you don't have to worry about it. And this is applying AI technology to do it. Okay, so with this, I would like to summarize. The next generation technologies and innovation will bring to us what? New ideas, openness, speed, performance, omnipresence, because it is ultra fast network connectivities with security, scale, and unlimited. With that, I'd like to just leave you and as young engineers or the parents of young engineers, some of the challenges. I would like to maybe without reading those, and give you some of my personal tips. And because I was kind of asked, then can we anticipate some people's interest, okay? And here they are. They are not in particular order. First, but I believe you needed to know what you want, okay? Not the parents. I re-emphasize is the young talent is what you like to do, who you are, what is your passion, what you enjoy to do, and you do it with fun. That is so important. The next thing is a continuous learning. Just don't view the learning as one time. You go to a best school, that's the end of your, no, it is not. The process, and it is a journey. So learn and practice, practice and learn and grow. Third is that find interest web. A lot of us, we giving out the career advisors, we say networking, networking, networking. Not the network of the physical network I earlier talked about. It's the human network. But I would encourage of you to form what I call the interest web. Interests web. So for example, if some of you listen to 3 talks today, you find the medical science to changing people's life, to save life, and to make the breakthrough in the next 10 years, as Dr. Zhang talked about, and break the vaccine, breaking those things for helping cancer patients. Great, then go into that field. If you form an interest group of that, making connection to Dr. Zhang and others, working in the field, that would be great, okay? Finally, keep an open mind. Keep an open mind. Most significant learning may coming from the places it's unexpected. You watch the things happening on the street. You go to a restaurant, you go to a supermarket store, all may give you unexpected idea to advance your learning, advance your interests, advance your invention to change the human society. With this, I thank you so much. I really appreciate the CIE, the DFW, the organization committee for such a wonderful event this afternoon. And I am flattered to be able to participate. Thank you very, very much. Appreciate it.
Thank you very much, David. And thank you. You touched actually my first question about advice to young engineer and students. We have a question about connectivity with IoT. So I'll read the question. The IoT use case success is limited despite of many tries. what should be done to better enable the IoT cases to business?
So, by the way, the interesting thing is about IoT is that I don't think that it can only driven by from the business side. I give you a simple example. AT&T has two largest business unit. One serves the consumer customer like you and me. We use cell phone as a service, right? Professor JC, you are the same consumer. But you work for a company, you work for a school, a university. That's a business customer, okay? So when you're talking about IoT, oftentimes either people working just from the consumer, just from the business side, okay? And they are trying to tackle, oh, I needed to develop this for the university department for research. I needed to develop this for Professor Chow, okay? But the reality is you have to merge the two together, okay?
Yes.
Just like a medical emergency, the thousands or millions consumer, they are ultimately are paying the money, okay? We are the consumers paying the money for the business. And you develop the thing just only for the consumer, it won't work because the business doesn't know how to connect. You're only working for the business, it may not serve the needs of the millions of consumer. I think the entrepreneurship needs to be bring down to very tactical to address the business, but the business has to address the business customer they are serving. And when you bring the two together, you'll be hitting a jackpot. Now, and also the other thing is that because of some earlier success, a lot of people believe IoT is just quick. You go back to write a few lines of code, you becomes a multi-billionaire, okay? Now, while we all envy how fast is someone turning into a multi-billionaire, I personally don't believe that anything like this nature can come in easily. I believe a model of hard working and a hard engineering working, research work to make things happen in the bolts and nuts and rubber meets the road levels. When you do this, have that kind of determination. And by the way, interestingly, if you go to California entrepreneurship, you go to a joint venture partnership, they all will tell you one thing. If you're looking for money, don't come to this door. If you're looking for innovation to how make things changing, then come, we will talk. All right. So I think the one is setting the right expectation. One is finding where you love to work on, you have a passion and energy for it, and you find the interesting group of web of interests and you work together. I think together, we as engineers, we are people with the STEM background, we will together working collaboratively to change the landscape.
Yes, and I do believe that the 5G and 6G with more connectivity, reliability, and capacity, and that is going to, in return, enable more IoT application. So could you unshare your screen, David?
Yes.
So I'm sorry, we're out of time. So I would, on behalf of CIE USA-DFW chapter, and would like to present an appreciation certificate to you. I would like to invite Convention Chair and CIE-DFW President, Dr. Tiger Zhao, and CIE-DFW Chairman, Dr. Lun Cai, to the stage, and we'll present this appreciation plaque to you and also take a photo.